Hi guys, today we're going to be talking about matrices. We will introduce a matrix, talk about dimensions, look at special names, subscript notation, we will add or subtract, and then wrap it up with multiplication by a scalar, also known as multiplication by a number. What is a matrix? So a matrix is pretty much a rectangular arrangement of numbers, something like we have. So it's like an arrangement of numbers in a rectangle form, and then the numbers or elements are written within a bracket. Now the question is, what is the size of this matrix? So that's where we look at dimensions. Oh, sorry, I chopped off the D. Okay, so the size of a matrix or dimensions of a matrix is just code for size of a matrix. The size of a matrix or dimensions of a matrix are determined by the numbers and numbers of rows and columns. Kind of like, think about like if it was a regular rectangle, and we will be like, what are the dimensions? We will say, oh, it's I don't know, 2 feet by 3 feet, so something like that. Okay, so let's go straight to fun problem 1. So we look at this matrix to answer the following. Question A reads, how many rows does the matrix have? So we go across 1, 2, 3. So to answer the question, we have 3 rows. Now next question is, how many columns does the matrix have? So we go down 1, 2, 3, 4. Okay, so now the question is, what are the dimensions of the matrix? So the dimensions, well, the matrix has 3 rows and 4 columns, so I'm at a crossroads. So I don't know if I should say if it's a 3 by 4 matrix or 4 by 3 matrix. Now to list the dimensions or size of a matrix, first we have to say the number of rows, then the number of columns. So rows first, columns thereafter. So in this case, the dimensions will be 3 by 4. Now, something that I overlooked was matrices are equal. How can we tell? Matrices are equal if they are of the same size and their corresponding elements are equal. I don't know what that means, so let me make it up. So let's just say I have a matrix. I'm not quite sure of the size. Yeah, I have no time to be creative. So I have a matrix with 2 rows, so this will be a 2 by something, and 3 columns. So I have a matrix that's 2 by 3. How can I tell if 2 matrices are equal? 2 matrices are equal if they have the same size. So I'm going to need another 2 by 3 matrix, and their corresponding elements are equal. So if the first row reads 1, 2, 3, then this other row over here has to be 1, 2, 3 followed by 4, 6. So then I'm like, are these matrices equal? Yeah. How can I tell? Oh, cause look, they look the same, but to be more explicit, the sizes are the same and the corresponding elements are the same. So we have 1, 2, 3, 4, 5, 6 in each entry. Okay, maybe I made this a big deal. Okay, moving forward. Now let's go ahead and look at the special names given to some of these matrices. So what is a square matrix? A square matrix is just a special name given to a matrix that has the same number of rows and columns. Kind of about thinking about a square. What is a square? It's just a special rectangle where all the sides are the same. So a square matrix is the special name given to a matrix that has the same number of rows and columns, or we'll call it order M. So looking at the examples that we have, I hope this video doesn't stop. Okay, cool. So looking at the examples that we have, for the third matrix we have 2 rows and 2 columns. So we have a 2 by 2 matrix. Number of rows and columns are the same, so we call it a square matrix. And the size, we can say 2 by 2, or we can say order 2. Okay, when we say order some number, the word order is exclusive to square matrices. What is a row matrix? A row matrix is the special name given to a matrix with just 1 row. So this matrix right here only has 1 row, hence row matrix. What are the dimensions? We have 1 row, so it'll be 1 by something, 1, 2, 3, and 4 columns. So it's going to be a row matrix. The dimensions are 1 by 4. Final special name that we're going to consider is a column matrix. What is a column matrix? A column matrix is the special name given to a matrix that has just one column, hence the last one in this example. So we have only one column, so special name column matrix. What are the dimensions? So remember, we say rows first, columns thereafter. So this matrix has 3 rows, so it's going to be a 3 by something followed by 1 column. So it's a 3 by 1 matrix. Fantastic. Okay, so now let's go ahead look at subscript notation. So it's very important to use subscript notation to like locate the names of the elements in this matrix. So first we say so we have the subscripts. In this case we have a sub 1 1. So the reason why it's called a sub 1 1 is because the first number corresponds to the number of rows, and the second number corresponds to the row number, and then the second number corresponds to the column number. So A11 is code for element in the row 1, column 1. So row 1, I'm right here, column 1, I'm right there. Now what about A23? Okay, so A23, row, column. How do we know it's row followed by column versus the other way around? Well, that's because that's how we listed the dimensions or the size of a matrix. First we say the rows, then we say the columns. So A23 is code for, I'm looking for the element in row 2, column 3. So row 2, we go 2 down, column 3, 1. This is 1, second column, third column. Yeah, that was fun. So let's go ahead and wrap up this page, not the video, with this fun problem. So it says what number is in the 1 1 entry? So 1 1 entry, so I'm looking for row 1, column 1. Okay, so row 1, I'm right here, column 1, first entry, so that will be 4. Maybe I shouldn't have tagged it, but I can't erase it. Problem B, what number is in the 2 1 entry? So 2 1, I'm looking for row 2, column 1. Okay, row 2, and then column 1, or that's right there, number 3. Problem C, I want to know what number is in the 2 4 entry. So 2 4, that's going to be row 2, column 4. So it's getting spicier. So row 2, column 4. So right here I'm at column 1 2 3 4. So that will give us 7. For the grand finale, I want to know what number is in the 3 2 entry. So 3 2, that's code for row 3, column 2. Okay, so row 3, 1 2 3, column 2. Right now I'm on the first column, and then I bump over, I'll be in column 2. Fantastic. Okay, so let me go ahead and look for my next page. Fantastic. So up next in the unit, what we are left with is with matrix addition and subtraction, and then we'll follow it by multiplication by a scalar or number. Okay, so now before we talk about how to add or subtract, important thing, we need to make sure that the matrices are of the same size, so same dimensions. If not, then we cannot add or subtract. Once we have verified that the dimensions are the same, then we can add or subtract entry wise. So like the 1 1 position with the other 1 1 position, and so forth. Okay, so problem A. So the directions read, perform the indicated operation if defined. So if I have 2 matrices separated by a plus sign, we're adding. If we have 2 matrices separated by a minus sign, yeah, you got it, we're subtracting. Okay, so let's do this. So first, let me go ahead highlight the size. You know, what if it's a trick question? The first matrix has 1 2 rows, so it's going to be a 2 by something, 2 by however many columns that we have. Okay, we have 1 2 2 columns, so the first matrix is a 2 by 2 matrix. Okay, cool. Next matrix, also 2 rows, so it's going to be a 2 by something followed by the number of columns, so 1 2, so it's going to be a 2 by 2 matrix. So the question is the sum defined? And the answer is yes, because the sizes are the same. So now we have green light to add. Now I know that you can add in your head, but I highly recommend that you speak to yourself, so show your thought process. So let's go ahead, add entry wise. So 1 1 entry plus 1 1 entry. So 0 plus 9, I know you know it's 9, but love yourself, show your thought process. 0 plus 9, let's go ahead and put that in the 1, 1 entry. Let's finish that first row. 1, 2 entry. That will be 8 plus negative 4. And it's like, why should we show work? Because it would be nice, but it's more for you. If you just go straight to the answer, like right now you're hot, but if you just have an answer key, how is that going to be helpful for a test, you know? All right, cool. Let's look at the next row, row 2. So we have 2, 1 plus the 2, 1 entry. So that'll be 2 plus 7. Let's go at the next column. That'll be negative 1 plus 5. Fantastic. So we did it. Let's go ahead, just add our numbers. So we have 0 plus 9 is 9. 8 plus negative 4 is 4. 2 plus 7 is 9. And then negative 1 plus 5, I'm having a moment, is 4. Oh, look at that. It's the same numbers. Yeah. Fantastic. Okay, so let's go ahead, look at problem B. So we have two matrices separated by a plus sign. So let's go ahead and add them. But again, what if it's a trick question? Let me go ahead and see if it's really possible. The first matrix, what is the size? 2 rows and by 3 columns. So it's going to be a 2 by 3 matrix. The next one, 3 rows and 2 columns. So we have 2 and 3 in both, but the question, are they the same? No, this is 2 by 3 and that's not 2 by something. So in this case, the only way we can add or subtract is if the matrices are the same size or same dimensions. So the directions read, perform the indicated operation. We just write something like it's not happening, but we can speak better than that. So I'm just gonna say that the sum is not defined. The sum is not defined. And if you wanted to put a little love note to yourself, or you just say like the sum is not defined because the dimensions are not the same. All right, fantastic. Let's go ahead, look at the third and final problem for this round. So we have two matrices separated by a minus sign, but I learned my lesson. What if it's a trick question? Let's make sure if the sizes are the same. So this one has 1, 2, 3 columns, so it's gonna be a 3 by something. I said that wrong. It has 3 rows, okay? Followed by 2 columns, so it's gonna be a 3 by 2 matrix, and we hope that we have a 3 by 2 matrix as well. The next matrix has 1, 2, 3 columns, so it's gonna be a 3 by something. It has 2 columns. I think I said it backwards again. The next matrix has 3 rows, so it's going to be a 3 by something, followed by 2 columns, so it's going to be a 3 by 2 matrix. So because the sizes are the same, then we have the green light to subtract. To subtract is the same way for addition. We're going to subtract entry wise. And again, I know you can add in your head, but love yourself, speak to yourself, show your thought process. So let's look at the first row. So we're going to have 6 minus 0 in the first column. Second column, 2 minus 5. And we're done with row 1. Row 2, first column will be negative 4 minus negative 7. Oh, negative 7. I almost forgot negative 7. Next column will be 1 minus 2. Cool, done. Row 3, 3 minus negative 1. 3 minus negative 1. Followed by 0 minus 0. So we spoke to ourselves, so when we give the answer, we will be able to see how we got that answer. Okay, so the first row, the elements, 6 minus 0 is 6, 2 minus 5 is negative 3, negative 4 minus negative 7, let me just go ahead and write it as addition, will give us 3, 1 minus 2 is negative 1, 3 minus negative 1, let's go ahead and write it as addition, that will give us 4, and then 0 minus 0, I feel like such a pro. Okay, so thanks to our hard work, we had just finished subtracting 2 matrices. Fantastic. Let's go ahead box these answers so to make it easier on the grader. Okay, problem B, or the next problem, it's a pretty spicy problem. That's a true test to see if we're really getting it. Okay, so it says find x and y so that the sum equals this matrix. Okay, if the sum has to equal this matrix, let's go ahead add, and then we'll see what to do next. Okay, so we have 2 matrices matrices separated by addition sign, we're supposed to add, but let's see if it's possible to add. This one is 2 rows and 2 columns, so it's going to be a 2 by 2 matrix. This one also has 2 rows and 2 columns, so we have another 2 by 2 matrix. The sizes are the same, so that means that the sum is defined. Let's go ahead and invest our time. So let's go ahead and add entry wise. First row, 4 plus -5. 4 plus -5. Next column, 2x plus -3. Row 1 done. Let's go to row 2. Row 2, -4 plus 5y. -4 plus 5y. Next column over, -3 plus 3. -3 plus 3. Okay, so this is what we have on the left. Okay, so on the left side, we have the sum of 2 matrices. And then we bring down the rest of the problem. We have an equal sign. And the left matrix should really equal the right matrix, which is given by -1, 1, 1, 0. Fantastic. So let's go ahead and simplify what we have. 4 plus -5 will give us -1. 2x plus -3. Well, we don't know what x is, but I'm just going to clean up the expression. Okay, -4 plus 5y, same speech. We're just gonna, oh, there's nothing to clean up. -3 plus 3 is 0. Okay, so I'm not quite sure where we're going with this, but let's just keep moving forward. So we have 2 matrices that are set equal to each other. If they're really equal to each other, then each entry should be the same. Okay, so let's look at the first row. -1, -1. Whew, I was having a moment for a while. -1 does equal -1. 2x minus 3 should equal 1. Okay, but we don't know what x is. That's the problem. We want to find x and y. But I know that this is row 1, column 2. I know that the 1, 2 entry should equal the 1, 2 entry from this other guy. So let's go ahead, set this equal to each other. The 1, 2 entry given by 2x minus 3 should equal the 1, 2 entry on the matrix on the right. Now let's go ahead and solve it. So we'll add 3 to both sides, and that will give us 2x is equal to 4. For the grand finale, after we divide both sides by 2, that will give us x equals 2. So 1 variable down, 1 more to go. Okay, so the next one, row 2. It's just in the first column, so it's the 2, 1 entry, and that should equal the 2, 1 entry on the matrix at the right. Okay, 2, 1 entry, 2, 1 entry. Okay, so the 2, 1 entry reads -4 plus 5y, and that should equal the 2, 1 entry on the right. Okay, so let's see let's just keep our cool and solve it. Isolate the y term by adding 4 to both sides. That will leave you with 5y equals, I believe, 3, and we don't have an integer, and that's okay. You can write this as leave it as a fraction, or write the decimal equivalent, which is 0.6. So we're done, but I just want to know if I really added correctly. So let's look at the next column over. So this is row 2, column 2. So this is the 2, 2 entry, and these matrices are equal. So this should be the 2, 2 entry should also match, and in this case, they do. Fantastic. All right, guys. So we're almost done. We're just one short problem away from finishing. Okay. So we're going to talk about how do we multiply a matrix by a scalar. That's just fancy talk for a number. Okay, so to multiply by a scalar or number, you're just going to multiply each element by 5. Okay, so you can show your work, or you can go straight to answer. I would love to show my work, but I'm out of space, so sorry guys. Okay, so 5 times the first thing we see will be -35. Next product, 5 times 3 is 15. Final product in that row, 5 times 0 is just 0. So done with row 1. Row 2, 5 times 4 will give us 20. 5 times -5 is -25. And 5 times 6 will give us 30. What do we do next? Nothing. That's it. We did it. We were given this matrix, and we were asked to multiply it by 5. We multiplied each element or each entry by 5, so we're good. Okay guys, so that's the end for this video. Thanks.